All right, so today we're knocking out 9.5 properties of logarithmic functions. All right, so there's 4 rules we're going to look at, and then we'll start doing the problems based off these 4 rules. And these are sort of similar to the exponent rules. So my first one I got is the product rule. So the product rule says if I got the log of a product, so I got a log base A, a m times n, this can be written as a sum of the logs. So a log a m plus a log a of n. All right, got a couple more coming in. All right, so like I said, product rule, I can rewrite a product as a sum of 2 logs. Then we got the power rule. So the power rule tells me if I got a log base a m to the p, this can be written as a product by bringing the p down to the front and having p times the log a of m. So basically this power rule is just bringing them exponents down and writing it as the product. Next, we got a quotient rule. So this is when I have a log of division. So if I had a log a of m divided by n, I can rewrite this as a difference of the logs. So the log base a m minus log base a of n. So just like the exponent rule, it's always the top factor minus the bottom factor. And then the last one, and this is used when we're simplifying mainly, but this is the log of a base to a power. And y'all, this tells me if I got a log base a of a to the x, so the base of the log is the base of the result raised to an exponent. If those match, then the answer will be just that exponent. All right, so these are the properties we're going to be playing with. So my first 2 problems, they say express as a sum of logarithms. Now notice, the only property up here that expresses anything as a sum of logs is the product rule. So they're going to give us a product, and we're going to rewrite it as a sum. So my first one, I got log base 11 of 11 times 121. All right, so we distribute the log 11 to both factors and rewrite it as a sum. So that'll give me a log base 11 of 11 plus a log base 11 of 121. Now, y'all, although this could go further, they just wanted me to rewrite it as a sum and be done with it. Now they're going to do, you'll notice they switch between logs and LNs on these problems. So this one has a ln of d times f. Same thing. I'm going to distribute the ln to both factors and rewrite it as a sum. So I'm going to get a ln of d plus the ln of f. All right, y'all, I got a sum. So we're done with that one. So these properties aren't bad if once you get used to them, okay? So these next two want me to write as a product. So we're going to express as a product. All right, let me let one in. Now, the only one that expresses things as a product is the power rule. So we bring the p down and write it as p times log a m. Okay, so when they say express as a product, we're using our power rule. And I guess up here I could have said when they express as a sum of logarithms, we're using the product rule. Okay, so number 3, we got a log base c of x to the 9th. So all I got to do is take the 9, bring it down to the front, so that this will give me 9 times the log base c of x. I've got my product, so we're done. Now 4 is going to be a little trickier. 4, I got the ln of a cube root of 10. Now the reason this one's trickier because I don't have an exponent showing. They got it in radical form. So I'm going to refresh y'all on a little rule we use to convert a radical into an exponent. So we can rewrite radicals as exponents, and it'll actually be a fractional exponent. So you bring out the base, which is a, and then this is going to create a fractional exponent here. The top number, if there's not an exponent by the variable or whatever's under the radical, if there's not an exponent on it, we treat it like a 1. So the top number of the fraction at least has to be a 1. And then the bottom number of the fraction is the index of the radical. So since n is the index, n becomes the bottom number, okay? So that's how we will convert from radicals into exponents. So on this one, I'm going to bring down the ln. 10's my base under the radical. And I'm going to rewrite this cube root as a fractional exponent. So notice that 10 doesn't have an exponent by it, so that's automatically going to be a 1. And then since that's a cube root, the bottom number of the fraction is a 3. So now I can invoke the power rule because I actually got my exponent now. So all we're going to do is bring the exponent down to the front, and that'll give me 1/3 times ln of 10. So y'all, that's going to be one of the trickiest things we're doing is converting from radicals to fractional exponents, okay? All right, the next two exercises want me to express as a difference of logs. So since I'm looking at a difference of logs, the only one that expresses anything as a difference is the quotient rule. So this one's going to be going over the quotient rule. So for 5, we have a log base b of b over 3. Now notice the base b is a little b, the b in the quotient is a capital B, okay? MathLab's very picky about lowercase and uppercase letters. So y'all, the quotient rule says it's the factor on top minus the factor on bottom. So I'm going to distribute log base b to both factors. So I get a log base b of b. So log base b of b minus the log base b of 3. All right, so that's written as a difference. So we're done. Number 6 is going to use LNs. So this one has ln of v divided by t. You know, this ain't bad. ln of v minus ln of t. Okay. Now, just remember in MathLab, these are LNs, not INs, okay? All right, so they're getting us warmed up doing this, okay? Just getting you used to these 3 properties. Because now we're going to rewrite as sums or differences. So all these properties are now in play, okay? So let's move on to number 7. So these examples, and we got about 6 or 7 of these. They want us to rewrite as sums or differences of logs. So all the rules are now in play. So for 7, they're giving me a log base d of x to the 4th, y to the 8th, and z. So the first thing you got to realize is you got a product sitting here. X to the 4th times y to the 8th times z. So since we got a product in here, we got to use the product rule and rewrite these as a sum. So we'll distribute log d to all 3 factors. So we'll get a log base d of x to the 4th plus a log base d of y to the 8th plus a log base d of z. Now I've got them rewritten as a sum. Now I got to do one more thing, and that means I got to now use the power rule because I got these exponents up here. And remember, the power rule wants me to bring my exponents down to the front and rewrite them as a product. So I'm going to bring this 4 down to the front, and that gives me a 4 log base d of x We got to bring this 8 down to the front. So I get plus 8 log d of y. And then I don't have an exponent here to worry about. So I just bring down my plus log base d of z. So y'all remember, when you're rewriting as sums or differences, you cannot leave those exponents up there. We got to bring them down using the power rule, okay? All right, so put a star by number 8, because you'll see this one again. I got a log base b. I got p squared q7 over m4 b8. So since we got a quotient here, we got division. When I rewrite this, the factors on top will be positive. The two factors on bottom will be negative. Okay, because it's always the top minus the bottom. So we're going to distribute log b to all 4 factors. But y'all remember, the top factors are positive. Because they're being added, and the bottom factors are negative because they're being subtracted. So here we go. We're going to distribute log b. So I get log base b of p squared plus log base b of q to the 7th. So the two factors on top, like I said, were positive. Now we subtract the two factors on bottom. So I get a log base b of m to the 4th minus my log base b of b to the 8th. All right, so I've written this with addition and subtraction like they wanted. Now we got to simplify this by bringing our exponents down to the front. But y'all, this log base b of b to the 8th, let me show you that. That looks just like my log of a base to a power. Log base b of b to the 8th. So that whole expression there is going to only equal the exponent. So when I get to this part, b of b to the 8th, this whole thing is going to equal that exponent of an 8. So if your bases match, the answer will be the 8, okay? Now, these 3, we will bring the exponents down. So I get 2 log base b of p plus this one gives me 7 log base b of q minus 4 log base b m. And like I said, you could bring the 8 down and make that a 8 log base b of b. But guess what? Log base b of b equals 1. So you'd have to do a whole nother step just to make that a 8 right there. Okay? So you got to get used to, if the bases match, it equals that exponent. And y'all, let's see, can't go no further, so we're done. So you just got to get used to the top factors being positive, the bottom factors being negative, okay? So here's going to be one using the LN. LN of 4 over 9 x to the 9th y. All right, so look at this. I got one factor on top. I got 3 factors on the bottom. I got a 9, x to the 9th, and a y. So when we rewrite this, the top factor is the only one going to be positive. All 3 of these factors will be negative. So distribute the ln to all the factors. So I got an ln of 4. So that's the only one positive. Everything else gets written as subtraction. So minus my ln of 9, minus my ln of x to the 9th, minus my ln of y. And y'all, there is only one thing I can do to this to get this into my most simplified form. And that is to take this one exponent and bring it to the front of its ln. So nothing else changes. I keep my ln 4 minus my ln 9 minus 9 ln of x minus ln of y. So all the exponents are now brought down. Nothing else we can do. So final answer. And y'all, guess what? Just when we think we started getting these things figured out, they're going to throw another radical on us. So look here, I got a log of a square root of a A7B. So the first thing we're going to do is convert this radical into a fractional exponent. So I'm going to bring down my log. Now I'm going to keep the A7B in parentheses and figure out what that exponent is. Since all this is under the radical, you want to keep them in parentheses when you do the exponent part. Now, remember the top number will be a 1. Oh, but y'all look here. There's not a number in the radical. Anytime there's not a number in that radical, you got to treat it like a 2. So square roots have an index of 2. So this will be written as a 1/2. Okay, so just remember, that's the only time we don't put a number on a radical, when it's a 2, okay? All right, so now we got to distribute that exponent into the parentheses. So I can bring down my log. Now, when you got an exponent raised to an exponent, you multiply. So 7 times 1/2 gives me an A to the 7/2. And then on my B, the B don't have an exponent. So remember, that's a 1 sitting there. And 1 times 1/2 gives us 1/2. All righty, so notice I got a product in here. And we rewrite products as a sum of logs. So distribute the log. So you got log A to the 7/2 plus log B to the 1/2. All right, so they're rewritten as a sum. And y'all, I got one more step to do. I now have to bring my exponents down to the front. So this one will give me a 7/2 log A plus a 1/2 log B. All right, y'all. Exponents are down, rewritten as a sum. Cannot go no further, so final answer. So y'all, basically this section, like I said, is just following them 4 properties and trying to get stuff rewritten as they want it, okay? So we got one more to do with the sums or differences, and then they go the other way. So let's see, I got a good one here, okay? I got a log base A, and then we got big parentheses here because we got a big radical here. And this is a 4th root. On top, I got an M20, N16. On bottom, I got an A3 and a B5. So y'all, let me tell you, when you got radicals, the first thing you really want to do every time is rewrite these radicals, okay? So let's bring down our log base A. So I'm going to get rid of the radical, so everything under the radical goes in my parentheses. M20, N16 over A to the 3rd, B to the 5th. So the only question is, what's this radical going to turn into as a fractional exponent? Well, since that's got a 4 in there for the index, the bottom number will be 4, and that means the top number will be a 1. So a 4th root turns into a 1/4 as a fractional exponent. All right, just like we did up here, we turned a square root into a half. Then I distribute that half through the parentheses. Well, we got to distribute this 1/4 through the parentheses to everybody in here. So let's bring down our log A. So for the M, 20 times 1/4. That's basically 20 divided by 4, which will give us the M5. On the N, 16 times the 4th is basically 16 divided by 4, which gives us a 4. Now, those two divided out nicely, but here I got 3 times 1/4, which is like 3 divided by 4. Can't do nothing in that. So I'm going to leave that A to the 3/4. And the same thing with the B, y'all got a 5. That's going to be like 5 divided by 4. Can't do nothing to that. So that's going to stay 5 divided by 4. All we've done so far was get rid of that radical. So we rewrote it without the radical. That's all we've done so far. Now, we're going to rewrite these 4 factors as sums or differences. Now, remember, the factors on top will be positive. The factors on bottom will be negative. So distribute log A to everybody. So I'm going to get a log A of M to the 5th plus log A of N to the 4th. So that's my 2 top factors, both positive. Now we work on the 2 bottom factors, both negative. So that'll give me minus log A of A to the 3/4 minus log A of B to the 5/4. So 4 factors, 4 terms. Now think about this one. This one, I'm going to bring the 5 down. This one, I'm going to bring the 4 down. This one, well, look here. I got a log base A of A to the 3/4. This base matches the base raised to an exponent. So this whole term right here is going to equal that exponent of 3/4. And then on the last one, I'll bring down the 5/4. Okay. So first, we bring down the 5. I get 5 log base A of M. The second one, I'm going to bring down to 4. So I get plus 4 log A of N. This one followed my base of a base to an exponent. So that's just going to be minus 3/4. And then on the last one, I'll bring down to 5/4 and I get negative 5/4 log A of B. And y'all, the place where I get most people is this part right here. Remember, that is simplifying down to the 3/4, okay? All right, so these are probably the worst ones because there's just so many steps on them, getting them out of them radicals, distributing the exponents, and then rewriting them, okay? All right. The last 6 problems for this section go the other way. So for these last exercises, they want me to take sums and differences and express them as a single logarithm. So express as a single logarithm. So we're going totally in the other direction. So for number 12, I got a log base T of 3 plus a log base T of 79. Well, look here. The only one that had anything to do with sums was the product rule. And it told me that if there was a sum, I could rewrite as a product. So for that one, we're going in reverse and writing it as a product. So I got a log base T of 3 times 79. And y'all, now all I got to do is figure out what 3 times 79 is, and this one will be done. So I get a log base T. So let's see, that'd be looks like I'm getting what, 237. So sums written in reverse give me products. All right, log 10,000 minus a log of 100. So these are being subtracted, and the only rule that did anything about subtraction was the quotient rule. And we rewrite the difference as a quotient. So break out the log. Now remember, positive stuff goes to the top. the stuff being subtracted goes to the bottom. So this will be 10,000 over 100. And I can divide that, and dividing that, 10,000 divided by 100 leaves me 100. So on MathLab, that's the first answer they want, is the log of 100. And then this further simplifies. Oh, that's simplifies. You know what I meant. Simplifies. So it further simplifies. Well, if I get my calculator and I figure out what the log of 100 is, watch this. I got a log on the front. So if I put in a log of 100, it's going to give me an exponent of, whoops, I didn't push the log, did I? All right, log of 100. Hit enter, and I get an exponent of 2. So remember, that's a log base 10. So that means to turn a 10 into 100, the exponent is a 2. So this number 13 is the only one where you had to take the log 100 and simplify that further into a 2. So that will have actually like 2 answer blanks on it, okay? All righty, so let's get into the fun ones. So 14 and 15 are some tricky ones here. So 14, I got 1/4 log C of X plus 4 log C of Y minus 3 log C of X. So when we're working in reverse to rewrite these as a single logarithm, our first step is to move these exponents back up. Remember, that's our last step when we rewrote them the other way. It's going to be our first step when we rewrite them as a single log. So kick all them exponents back up. So this will give me a log base C of X to the 1/4. Plus log base C of Y to the 4th. Minus log base C of X to the 3rd. And y'all, that's the trick on these, is just working all them properties one by one. So notice, exponents are all up. Now I'm going to rewrite it as a single log. Positive factors will be on top. And since I got one being subtracted, that's going to be on the bottom like a quotient. So break out that log C. The factors on top will be the X to the 1/4, the Y to the 4th, and the factor on bottom will be the X to the 3rd. So we would technically be done on this, except for one thing. I got X's on top, and I got X's on the bottom. So since I got X's over X's, the trick here is to use the quotient rule of exponents. And that tells me that I always subtract the smaller exponent from the larger exponent and keep the answer where the larger exponent was. So since the 3 is bigger than the 1/4, I'm going to subtract 1/4 from 3 and then put that answer in the bottom. All right, so let's see. 3 minus 1/4. Hell, we got a calculator, right? So let's go. So 3 minus 1 divided by 4. Now remember, I'm going to get a decimal at first, but I'm going to hit math and enter twice and turn that into 11/4. So that means I got my log base C. So that gave me what, 11/4? So the x on top is gone because when we subtracted exponents, since the bottom was bigger, that's the only place the x will be. So only thing left on top will be the y4. On bottom will be the x to the 11/4. Now, I ain't gonna lie, this one's a bear to put in Math Lab. Because once you put in the log and the subscript C, you put a fraction here, put in your y4s, and then when you click down on the bottom and put in that x, you got to click the exponent and make it a fraction. Okay, so this one's tricky in Math Lab to put in. So if you have issues on that one, I can help y'all out in Math Lab, okay? All right, so 15 is going to be another tricky one like this.
Mr. Rathbun, before you get started on 15, could you show us how you would put the simplified answer of 14 into the calculator? Or is that the simplified answer? We don't, like, you're not going to have to do it like 13 and find 2, like we did the log of 100 and it simplified further to 2. It's not going to want that for 14, is it?
No.
Okay, great.
No, it just wants this answer right here.
Okay, great. Then disregard that. Never mind.
Yeah. Only reason they wanted this one fun because it actually had numbers here.
And you could actually type that one into the calculator.
Yeah. So, all right, y'all, ln x to the 4th minus 3 ln a cube root of x squared. So y'all, the very first thing I would do to this is convert this radical. So I got a cube root of an x squared. So bring out the x. This time, since my variable has this exponent and it's the only variable under here, that means my top number will now be a 2. And then the index of the radical will still be the bottom number. Okay, so if you got a single variable with an exponent, that becomes the top number of the fraction. So y'all, this turns into a ln of x to the 4th minus 3 ln. And this radical now turns into a x to the 2/3. So that's all we've done so far was converted our radical. Now, this exponent's already up here, but this 3, we have to bring the 3 back up. And when you bring up an exponent and there's already an exponent there, you multiply those exponents. So we got to figure out what 3 times 2/3 is. Well, y'all, that's going to be 3 times 2 is 6/3. And that 6/3 will simplify to a 2. So this gives me a ln of x to the 4th minus ln of x squared. Okay, so basically you brought the 3 up, they canceled. All that was left was the 2. So now exponents are up. I've got stuff being subtracted. So since this is being subtracted, we're going to write it as a single log in the form of a quotient. The positive factor, x4 on top. The factor being subtracted, the x squared, goes to the bottom. Oh, but y'all look here. There's actually one more thing I can do here because remember, I got x's over x's. This time, the higher exponent is on top. So I would subtract 2 from 4, and that would leave me what? A ln x squared. So I had to subtract exponents on this one. Also, we had to subtract exponents up here on this one. So here we left the x in the bottom because the x was bigger in the bottom. Here, the x is left on the top because the top was larger. So those are probably some of the trickiest problems is these two right here, okay? So now we got 2 more left in this section. So let me see what we got here. All right, y'all, these last two, what they say is simplify the expression. All righty, so 16 has the ln of x squared plus 16x plus 60 minus a ln of x plus 10. All right, so the only thing we can do with this one right off the bat is rewrite it as a single logarithm. So this one's being subtracted, so it's going to look like a quotient again. So break out that ln. The top will be this positive factor. So the x squared plus 16x plus 60 all over the x plus 10. So y'all, here's the thing with this one. When you got a rational expression like this, to simplify this, we got to see if there's any factors on top that'll cancel with this factor of an x plus 10 on the bottom. Now, you can't cancel out single x's and single numbers. We got to be able to cancel out that whole x plus 10 with another x plus 10 from the top. Well, to find that out, we're going to have to factor the top. So we would bring down our ln. The top is going to factor into 2 parentheses. And then the bottom will still be the x plus 10. So remember, x squared is the x and the x. Last number is positive, so both factors will be positive like the middle number. Now think about it. If anything's going to cancel, one of these two numbers has to be a 10. So what factors of 60 add to get me a 16?
10 and 6.
10 and 6. Well, guess what? I now have a factor that's going to cancel. So that x plus 10 cancels out. And y'all, our final answer, now here's where you got to be careful. You got to keep the x plus 6 in parentheses on that answer. Because if you write ln of x plus 6 without parentheses, it will count it wrong because the ln would only apply to the x and not to both. So this one definitely has to be kept in parentheses. And y'all, basically on 16 and 17, that's all we're doing. Factoring and canceling and then writing our final answers. All right, so that was with the ln, so they did one with a log. I got a log of x squared plus 10x plus 21 minus a log of x squared minus 9. So the only thing we can do is rewrite it being subtracted as a quotient again. So bring out the log. So y'all, let's see the positive factor, x squared plus 10x plus 21 will all be over the x squared minus 9. So y'all, here's the thing on this one. The top and the bottom will factor on this one. So we've got to factor both the top and bottom to see if anything's going to cancel out. So the top will definitely factor into 2 parentheses. The bottom, that's the difference of perfect squares. It's going to factor into 2 parentheses. So y'all, on top, that's positive. So both of these will be positive like the middle. What factors of 21 give me a 10?
7 and 3.
Now, x squared is an x and an x. Now remember, these perfect squares always factored into conjugate pairs. So the square root of the x squared went in front, square root of 9 will go in the back. So y'all, what is the square root of 9?
3.
Oh, what'd y'all just say?
The square root. Oh, I'm sorry. You said the square root of 9. 81.
Oh, don't square it. Go the other way.
3.
3. There you go. So does y'all check this out though. X plus 3's match on top and bottom, right? So cancel out those x plus 3's. So my final answer will be a log. Now this one, since I got a fraction left, you don't have to use the parentheses. Because when it's in fraction form, MATLAB knows that this is your numerator and this is your denominator. Now, you can put parentheses and it'll count it right, I believe. But just remember, you don't have to use them on that one. So y'all, that is 9.5 for college algebra. So what I'm going to do now is go over the 9.5 support. And y'all, it's only got 5 questions. And it just goes over some of those exponent rules. So this will be 9.5 support. And whoops, y'all can't see that. I'm going to write the exponent rules real quick, and then we'll knock out these problems, okay? So you got a product rule of exponents that says if you got x to the a times x to the b, we add exponents. So x squared times x to the third equals x to the fifth. You added exponents when you multiply variables. Power rule is used when I got an exponent raised to an exponent. So a to the m raised to the n is just a m times n. So when you got an exponent raised to an exponent, you multiply the exponents. So it almost matches those logarithms, right? Product rule of logs. When I had a product, I rewrote them as the sum of exponents. The power rule, I brought that exponent down and we multiplied the exponents. Quotient rule tells me if I got something like x to the a over x to the b, that equaled x to the a minus b. So we subtracted exponents when we had our x's over x's while ago. All right, we got negative exponent rule. So if you got x to the negative a, we make the exponent positive by flipping that. So remember, treat it like a 1 on bottom. So you're flipping it and making the a positive. Now, if the a's in bottom and negative, you would move it to the top, okay? So y'all, these are the exponent rules that are sort of going to be playing with on this section. So look here for number 1. X to the 5th times x to the negative 8. So x times an x, I got the product rule going in effect, which tells me to add the exponents. Well, 5 plus negative 8, that's going to give me x to the negative 3rd. But y'all, we got to write our answer with positive exponents. So look, I'm going to have to follow this negative exponent rule, which tells me if I got a negative exponent, I put everything under 1 and change the sign of the exponent. So that this will give me 1 over x to the 3rd. All right, let's see what we have here. Y to the negative 4 times y to the 9th times y to the 8th. All these y's are being multiplied. That means we get to add all 3 of these exponents. So let's see. Negative 4 and 9 give me 5. 5 plus 8, that gives me what, 13. So this gives me y to the 13th. My exponent's positive, so I don't have to do anything else. So if you notice, these support problems were getting you ready for doing those problems I just did while ago in 9-5, okay? All right, y'all, so let's change it up. 9x squared times 2x to the 4th power. So I can't do nothing inside these parentheses. So I'm now going to distribute these exponents. So with the number 9 squared, that's going to be 9 times 9. So that's what, 81. Now check this out. You got an x squared being squared. Well, y'all, that's the power rule. Exponent raised to an exponent. We multiply the exponents. So that'll give you an x to the 4th. Now over here, 2 to the 4th. 2 times 2 times 2 times 2 gives you 16. Now remember, this x don't have an exponent, so we treat it like a 1. And 1 times 4 gives me an x to the 4th. So remember, at this point, I'm using the power rule. Now, I'm going to multiply 81 times 16. That's going to give me 1296. X. So let's see what I'm going to do here. I got an x times the x. So I'm back up here to the product rule. X times x wants me to add exponents. So 4 plus 4 gives me an 8. So y'all, you got to be careful. When am I multiplying the exponents? I got the power rule. When I'm adding exponents is when I got a variable times a variable, and I'm using the product rule, okay? All right, y'all, this one's not bad. A B7 over a b negative 2. Well, y'all, I got division, so I got the quotient rule going on. And it tells me to take the top exponent and subtract the bottom exponent. So, y'all, what y'all got to figure out, what is 7 minus a negative 2 going to give us? And that'll be the exponent of that b. Well, guess what? When you subtract a negative, that basically becomes a positive. So I basically got 7 plus 2, which gives me a 9. And that's our final answer. All right, then one more going over that power rule. 4x to the 8th, y to the 6th, and all this being squared. So, y'all, the first thing, we need to figure out what 4 squared is. So that would be, what, 4 times 4, which would give us a 16. On the x, you got an exponent of 8 raised to an exponent of 2. You're going to multiply those exponents and get a 16. And then on the y, you got an exponent of 6 being squared. So we're going to multiply those and get a 12. Y'all notice the difference. When I added them, I had the variable times a variable. When I multiplied, I got exponents raised to exponents, okay? So y'all, let's see, 1, 2, 3, 4, 5. That's your support for this lesson. So y'all, questions on this? So remember, the support's following your exponent rules, which are really similar in a way to those logarithmic rules. Because you got to remember, in the long run, logarithms are exponents, okay? So that's why they're sort of similar. Although they're different, they're similar, okay? Alrighty, y'all, so let me stop that share. So, questions over today.